Sustainability is challenging. From definition to implementation, it's complex and diverse and requires innovative solutions to serious problems. A big part of solving sustainability issues is changing the way we think about and analyze problems and their possible solutions. Here at the School of Community Resources and Development, we collaborate with other schools within ASU to find creative, interdisciplinary solutions to pressing problems. This entire course will be using 5 key concepts developed by the School of Sustainability at ASU. These key concepts are paramount to the successful, long-term solutions that we're hoping to achieve. The first key concept is the idea of systems dynamics. What does this mean? Well, human systems and natural systems are linked. Changes in any part of any system have multiple consequences that reach far beyond the initial change. This means that we must start thinking of things in systems terms. We must step back and look at everything we do, every policy we implement, or every product we create as a part of a system. In the case of products we consume, we must look at extraction of raw materials, production, packaging, distribution, consumption, disposal, or reuse. And we must look at these things from a social, economic, and environmental perspective. This goes for any decision we make as well. An environmental policy has social and economic implications, and a social policy has environmental and economic implications. Thinking in systems terms gives us an awareness that allows us to develop policies and programs that change the source of the problem rather than just responding with another quick fix and dealing with the symptoms. Thinking in systems is fundamentally different from traditional forms of analysis. In fact, the word analysis actually comes from the root meaning to break into constituent parts. For sustainability, we must look at what we're studying as a part of a whole and how it interacts with the system. So instead of isolating smaller and smaller parts of the system, we must expand our view and take into account larger and larger numbers of interactions between parts of the system. After this course, you'll be able to look at tourism as a sum of its systems. You'll recognize that for tourism to be sustainable, you must successfully be able to address which systems are involved and how to address each one in the most sustainable way possible for the situation. There is never one answer to sustainability problems, nor is sustainability a final destination. The student of sustainability recognizes that it is a process and a constant balance in the face of ever-changing variables. This course will break down the different systems involved in sustainability and help train you to recognize the connections between them. Now, because everything is a part of a system, many of which we do not entirely understand, human policies, decisions, and actions, all of which have implications for sustainability, can result in cascading effects. These can be positive or negative, intended or unintended. Ecosystems, for example, are extremely complex, and we're only now realizing just how difficult it can be to predict how ecosystems will react to human interactions. A classic example of this is the near extinction of the sea otter for their pelts during the Great Hunt from the mid-18th century until 1911. Although it was clear that numbers were dropping, the cascading effects of this hunt meant that the loss of the sea otter resulted in other dramatic effects. As a keystone species and predator, the sea otter fed primarily on sea urchin. With the sea otter nearly gone, sea urchin populations exploded, and the sea urchin then began feasting on kelp. As the kelp decreased, so did the sea urchin population, as well as the many other species that live in the kelp forest ecosystem. The loss of the sea otter population resulted in a cascade effect of secondary extinctions, leaving a formerly thriving ecosystem nearly barren. Despite a ban on sea otter hunting in 1911, many populations of species that suffered have not yet recovered. You'll learn in Unit 4 how the destruction of mangroves for tourism development is having cascading effects well beyond the destruction of the mangrove itself. But cascading effects aren't unique to ecosystems. It's any chain of events that are directly related to a change in the system. Understanding how systems work, we can be better prepared to minimize negative cascading effects. Often, a change in the system won't necessarily lead to a chain of events, but may have a direct consequence to the action that we were not prepared for and was not a part of the original goal. This is called an unintended consequence. A good example of this is the purposeful introduction of rabbits to Australia. Rabbits were introduced to Australia from Europe as a source of food in 1859. Since then, their effects on the ecology of the country have been devastating. They are suspected of being the most significant factor in species loss in Australia. They're also responsible for erosion problems as they eat native plants and leave topsoil exposed. This is an example of an unintended consequence to an intended action that was meant to be beneficial. Another example of an unintended consequence revolves around genetically modified crops. There have been many demands on this industry to be able to better predict the consequences of genetically modified foods to humans and animals. A genetically modified strain of cotton that was created to be resistant to bollworm pests in order to reduce the need to deal with insecticides has resulted in an infestation of mirid bugs, which are attacking their own farms and invading farms of other vulnerable crops nearby. The findings mark the first confirmed report of a mass infestation arising as an unintended consequence of farmers using less pesticide due to the features of a genetically modified crop. This demonstrates the need to look at the entire system to see how one change in it can affect others and can have dramatic implications. As we become more aware of how interlinked all systems are, we're working to be better prepared to model out potential consequences and cascading effects. When reading the course content, think about some of the problems that tourism development can present and what possible solutions to these problems may be. Then try and consider what the effects of your hypothetical solutions or ideas may be on the different systems you'll be learning about. Is it possible to avoid as many negative consequences and effects as possible? The second key concept focuses on the idea of trade-offs. Solving almost all problems related to sustainability involves trade-offs. There are rarely perfect solutions with no costs, and there are often winners and losers. We are faced with trade-offs every day in our personal lives, and decision makers and managers are no different. As students, many of you have full-time jobs as well. You have decided that the trade-off of less time with friends or family so that you can further your education is worth it in the long run, and a trade-off that you're willing to accept. Sustainability is fraught with trade-offs. Focusing on the environmental aspect may have a temporary or permanent economic trade-off, or vice versa. Making a decision based on just economic or environmental motives is short and narrow-sighted. Tourism is particularly challenging because so many different stakeholders are involved. It isn't easy to determine what trade-offs everyone is willing to accept. Dams are a great example of trade-offs. A dam can be a source of clean energy to replace the use of dirty energy sources such as oil or coal. However, there are serious environmental and social trade-offs. Often, the building of a dam can displace thousands, even millions of people, and dramatically and permanently change surrounding ecosystems. In some cases, the trade-off may be worth it. In other cases, it may not be. Is the loss of a valuable ecological resource to a hotel development project worth the economic gains over the environmental losses? Solar energy is another example. Many think it's the perfect solution, but as I said, there are no perfect solutions. Everything has a trade-off. Solar panels take up mass amounts of space, and this can have serious environmental effects when you consider the roads and water needed to access and maintain solar panels. They're also very expensive, and for some, the initial investment isn't worth the long-term economic gains if it means that a business won't be able to survive the short-term outlay of cash to purchase and install. Sometimes the trade-offs are easier to decide and agree upon. Other times, it's much more complex. For example, in the United States, beginning in the 1940s, large volumes of the chemical DDT were sprayed outdoors to kill mosquitoes and pests on crops. It was banned in 1972 after it built up in food chains, nearly wiping out bald eagles, pelicans, and other birds, and was considered to be a long-term health risk. It would be easy to say that DDT should be banned, as many people worry about its environmental and long-term health effects. But in many countries, where malaria kills nearly 1 million people a year, the use of the chemical is still promoted. This is a trade-off that must be balanced and addressed. While reading each of your units, take time to consider the trade-offs to the solutions of some of our more pressing sustainability problems. How do we come up with solutions that are more equitable, even if we know that there will be some winners and some losers? In other words, how do we minimize the negative trade-offs? The third key concept deals with scale. Problems of sustainability exist on multiple scales. Solving a problem at a local level is very different than solving one across international boundaries. Equally, our actions on a local level can have implications on a global scale. Consider the uniqueness of the Arizona desert. Solving problems of food production or water issues here will be very different than in many other places in the world. How we solve problems here may have global impacts and vice versa. Global sustainability problems affect our daily lives in Phoenix. This is the idea of scale, and recognizing the importance of finding the best ways to solve problems on a local, regional, and global level, and how the policies and actions at each scale affect everyone else. As you learn about many of the problems facing us today on a global scale from the course content, try and relate these things to your local environment. What things do you do in your home, city, or state that affect other people in the United States or around the globe? What actions happening in other countries are having an effect on you closer to home? What role does tourism have in contributing to how we recognize global problems? What can be done on a local level when managing tourism development that can help on a global scale? The fourth key concept is the idea of long-term development. Sustainability is not looking for a quick fix. We are trying to provide for our needs and protect our environment while allowing future generations to do the same. This is not an easy task. Sustainability hinges on an understanding of long-term consequences of the decisions that we make today. Solutions that work in the short term may pose problems over a longer time frame. Challenges that seem small in the present may magnify over time. The speed and style that we develop may not be conducive to the speed at which Mother Nature works, and may have serious implications for future generations. What makes sustainable tourism challenging is that we're essentially providing a product to ever-fickle populations who are often more demanding and less flexible. Can we look at the long-term development of a tourism destination while meeting the short-term needs of tourists who bore easily and demand instant gratification on their trips? You can't tell a tourist that they'll appreciate what you've done in 10 years if they want their vacation today. Finally, we must address the need for collaboration and participation. Sustainability problems are caused by and affect multiple stakeholders with specific experiences, resources, perspectives, and preferences. Solving sustainability problems requires strong collaborations and negotiations. There is no one solution to address sustainability, and no one person has the answer. We need scientists and social scientists of all disciplines, politicians, entrepreneurs, artists, farmers, businesses and community leaders, and you to work towards a sustainable future. As is evident by the content in all of your courses, people from all disciplines and all walks of life, like yourselves, are needed to solve these complex sustainability issues. They cannot be compartmentalized into distinct schools, and they transcend the social, natural, formal, and applied sciences as well as humanities. Each time you learn about a sustainability issue, try and write down the different ways your unique background affects how you view this issue and what you can do to help contribute to solutions. To review, the 5 key concepts that you will master through this and all of your sustainability courses are systems dynamics, which includes cascading effects and unintended consequences, trade-offs, scale, long-term development, and collaboration and participation. Refer back to this lecture often and make sure you apply this new way of thinking to information presented to you in this and all of your courses.